ఆ మధ్యలో గూగుల్ అనేది వచ్చిందిరా. So let us draw the graph between concentration and time. Molar concentration. Concentration of reactant decreases. A is reactant. Concentration of product increases. At one stage, concentration of A or B remain constant. Okay, this A minus X. This value remain constant, that is at equilibrium stage. Okay, what is the role of catalyst? Role of catalyst is it equally increases rate of forward and rate of backward. Equally increases rate of forward and rate of backward. So in presence of catalyst, equilibrium is attained rapidly. It helps to attain equilibrium rapidly. Catalyst helps to attain equilibrium rapidly. That is the role of the catalyst. At equilibrium, what are constant? Concentration, temperature. At equilibrium, concentration remain constant. Okay. You start with reactants or product, you can attain equilibrium. You start with A or start with B. Equilibrium can be attained from either of directions. Can be attained from either of directions. Left hand side or right hand side. Equilibrium can be attained from either of directions. Start with reactants or start with products. You will get equilibrium at the same conditions. Okay. Next one, which one influence equilibrium position? Concentration, temperature, pressure, inert gas. Addition of inert gas influence equilibrium position. Influence equilibrium position. Okay. You change equilibrium, concentration, equilibrium shift. Okay. You change temperature, pressure. Equilibrium is shifted. Okay. This concentration, temperature, pressure and inert gas influence equilibrium position. Okay. Now let us study equilibrium constant. Kc is constant. So use the law of mass action. Rate directly proportional to concentration. Moles are powers. Suppose I am taking A gives B. Rate of forward directly proportional to concentration of A. Rf is equal to Kf into A power square. The square bracket represents molar concentration. It represents molar concentration. Similarly, rate of backward reaction directly proportional to concentration of product. Moles are powers. Rb is equal to Kb into B power 3. At equilibrium, two are equal. At equilibrium, first equation is equal to second equation. Rf is equal to Rb. So substitute this A power 2 B power 3. Kf by Kb. Ratio of the rate constants B power 3 A power 2. Kf by Kb is equal to Kc. Right. Just simply applying the law of mass action, rate directly proportional to molar concentration. The moles are raised to powers. Moles means stoichiometric coefficients. What is stoichiometric coefficient? 2. 3. 2 and 3 are stoichiometric coefficients. The number of moles in balanced equation are known as stoichiometric coefficient. Number of moles in balanced equation are known as stoichiometric coefficients. The stoichiometric coefficients are raised to powers. Okay, simply products by reactants. Simply products by reactant. The equilibrium constant. For example, I am taking N2 plus 3H2 gives ammonia. Haber process. Write equilibrium constant. Just products by reactant. What is the product here? Ammonia. What are the reactants? Nitrogen and hydrogen. Nitrogen and hydrogen are reactants. That is Kc. Simply write products by reactants. Okay. Equilibrium molar concentration of ammonia, equilibrium molar concentration of nitrogen and hydrogen. Okay. Suppose you take nitrogen plus hydrogen gives ammonia. The initial concentration A, it is B, it is 0. Initial T is 0. T at equilibrium. A minus X, here 1 is there. Here how many moles? 3 moles. B minus 3X, here 2X. X disappear, 3X disappear, 2X appear. Take the moles. Here 1 mole disappear, 3 moles. So I take say X, here X disappear, 1 into X. Here 3X disappear, 2X appear. Equilibrium moles, equilibrium concentrations. A minus X by V liters, B minus 3X by V liters, 2X by V liters. Moles by volume. Moles by volume. T is equal to 0 moles. N0. Here N equilibrium. Here concentrations. Concentration means this. Equilibrium concentrations. Equilibrium concentrations. So we want to find suppose Kc. Products by reactants. What is product here? Ammonia. 2X by V whole square. What are reactant here? Nitrogen, hydrogen. A minus X by V. Hydrogen B minus 3X by V. So X is given in the examination. You can find Kc. What are given? A X V are given. B X V are given. 2X V are given. These are given. So you can find Kc. So equilibrium concentration of products by equilibrium concentration of reactants. Let us take PCl5. It decomposes to gives PCl3 plus Cl2. Initially A is 0. T is equal to 0. Equilibrium moles. Equilibrium moles. A minus X. 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 Equilibrium concentrations. A minus X by V. X by V liters. Volume in liters. Moles by volume is molarity. What is molarity? Number of moles of solute present in 1 liter of solution. Number of moles of solute present in 1 liter of solution. Moles by volume. Moles by volume, moles by volume. Kc is equal to concentration, equilibrium concentration of products. Equilibrium concentration of products by equilibrium concentration of reactants. What is equilibrium concentration of PCl3? X by V. It is Cl2 X by V. Okay. Here A minus X by V. A minus X by V. It is Kc. We can find Kc value. Okay. Kc is equilibrium constant. Kc depends on temperature. Kc depends on temperature. Kc depends on stoichiometry. Equation. Stoichiometry. Stoichiometry means how many moles are there. How many moles are there in balanced equation. Stoichiometry of equation. It purely depends on temperature, depends on stoichiometry. Okay, for given reaction, Kc is remain constant. For given reaction, Kc remain constant. A2 plus B2 gives 2AB, for example. Okay, what is Kc? AB square. A2 molar equilibrium molar concentration, B2 equilibrium molar concentration. Just I am changing stoichiometry. 1 by 2 mole, 1 by 2 mole, 1 mole. 1 by 2 mole, 1 by 2 mole, 1 mole. What is Kc? Concentration of AB, power is 1. Concentration of A2, power is 1 by 2. Moles are 1 by 2. B2 power 1 by 2. Okay, these two are not same. Kc1, Kc2, they are not equal. But here reaction, stoichiometry is different. 1 by 2, 1 by 2, 1. Here 1 plus 1 gives 2. Here moles are different. The reaction is same, but stoichiometry is different. Reaction is same, stoichiometry is different. Here 1 by 2 mole, 1 by 2 mole, 1 mole. Here 1 mole, 1 mole, 2 mole. So stoichiometry depends on stoichiometry. So endothermic change and exothermic, delta H less than 0 exothermic. Two reactions are there. Greater than 0 endothermic. Okay. Two reactions, exothermic, endothermic. Exo means heat is liberated. Exo means liberation of heat. Heat is liberated, released. What is endo? Heat is absorbed. Heat is absorbed. Endo and exothermic. So with rise in temperature, see, so the exothermic reactions, endothermic reaction. As temperature increases, Kc of endothermic reaction increases. As temperature decreases, Kc of exothermic increases. Temperature increases, Kc of endothermic increases. Temperature decreases, Kc of exothermic reaction increases. Two reactions, endo, exo. Temperature increases, Kc of endothermic reaction increases. As temperature decreases, Kc of exothermic reaction increases. Okay.